spectacular.
What was the effect of these new varieties once they got to India in terms of food production?
These were tremendous increases in yield.
How much?
From, let's say, 10 bushels to 80 bushels an acre.
So they were only producing 10 bushels per acre of wheat before these varieties came?
Yes.
So it's a tenfold increase in yield?
Yes.
It's phenomenal.
And this shook up everybody. Suddenly here, Pakistan is self-sufficient, and India is going in that direction fast. A green revolution seems to have happened.
Dr. Skovman, Simmet has played a major role in the Green Revolution. In fact, one could say that the Green Revolution started here with wheat. What was the work that was carried out here at Simmet that kicked off this whole Green Revolution?
Well, it was the early work by Dr. Norman Borlaug, who brought several traits into new wheat varieties. One trait was a gene for dwarfing the plants, making them smaller, meaning that they could utilize more inputs like water, fertilizer, nitrogen.
So the wheat was engineered to be shorter, and what were the advantages of having these little short wheats?
If you put much fertilizer and water on a tall plant like this, you'll get a result, is what we call lodging, where the wheat falls down on the ground, and then it doesn't really matter what you do with it, you're not going to get any yield out of that plant.
So in simple terms then, this wheat is just too tall, it just falls over.
Right.
And what was the effect of this when it was released into India after it was engineered here?
That year was the first year that India actually could export wheat.
In the 20th century, the same changes have been taking place in developing countries as took place in Europe and North America before that. Medical advances and improved infrastructure, at least in urban areas, have led to a decline in infant mortality and therefore a growing population. But these people had to be fed, and many experts believe that without the work of Dr. Borlaug and others, poor countries like India would have faced disaster. I spoke to agricultural scientist Dr. M.S. Swaminathan, who was the first person to win the World Food Prize for his part in the Green Revolution.
So what would have happened in India without your work establishing these new genetic varieties?
If new genetic varieties had not been available from the mid-60s, India would have had a series of famines of a disastrous nature. And between 1870 and 1900, 30 million people died out of starvation. That was traditional farming, traditional methods. The traditional ways of farming were associated with recurrent famines.
We would have simply had massive starvation and famine if we didn't have this Green Revolution. We probably would have farmed every square inch of land and still not be able to produce the kind of food that we are doing today. And so the Green Revolution was one of the most significant scientific accomplishments of India and many countries in the past century.
But there are those in the West who disapprove of the Green Revolution and the transfer of modern agricultural techniques to the Third World. Instead of developing countries adopting the scientific practices of the West, they argue that the West should be adopting the simpler, more primitive methods of agriculture common in countries like India.
I am terribly concerned as a consumer, as a mother, as a business person, as a citizen of this planet, that we meaning the Western world, are imposing our big business, big farming skills on cultures that have already been harmed, that are dying out. It's a detriment to our future world.
I can understand how people can be mesmerized by the culture of places like India. But what is life really like for people who practice subsistence agriculture? I decided to travel to India to find out for myself. It's not hard to find subsistence farming here, as I discovered when I took a short drive out of the capital, Delhi. I was going to a village to meet local journalist Barun Mitra and to see what rural life was like at first hand.
And how are you? What's going on?
Yeah, great to meet you.
This village is typical of many villages in India, and indeed the rest of the third world. Homes have no running water or electricity, and everyone works on the land. I wanted to ask Barun if modern agricultural technology was appropriate in such a village.
There's people who say that the Green Revolution was actually harmful to India.
I mean, look at it this way. In the last 50 years, India's population has tripled. India's food production has quadrupled. Without the Green Revolution, we would have been back in the days when millions in this country starved to death. You know, the last famine India has had, the last major famine.
When was that?
Was in 1943, when about 3 million people in my state of Bengal, and which is currently Bangladesh, died. 3 million people died of famine in 1943 in this country. We haven't had a famine of this kind since. This year they talked of a drought. The media went round the country trying to figure out who died. They virtually found none. India has made enormous agricultural progress. The point is we have not progressed fast enough, far enough.
But primitive agriculture doesn't just lead to a lack of food and poor diets. It also means that countries which are overwhelmingly agrarian cannot afford the modern amenities which we take for granted.
What are these things over here?
These are dung
What
cakes.
is this?
It's the principal form of fuel because there's no electricity and wood is in short
They're
supply.
burning this.
They're burning this. You see here, this is a typical kitchen and you see the dungs burning.
And they live in this? This is in their huts, this smoke?
Yeah, this smoke normally stays within the hut for a long time because
And these children aren't breathing this smoke
all the time, yes.
80% of the people in India are forced to burn wood or dry dung to cook their food and heat their homes because they have no electricity. And the air pollution from this is deadly. According to the World Health Organization, 500,000 children die in India every year from respiratory diseases brought about by indoor smoke and rural smog. This form of third world pollution alone is far more damaging than all the environmental problems of the industrial West combined. And it's not just air quality. Villages like this cannot afford the modern water cleaning facilities which we have in the West, and the resulting waterborne diseases can be deadly. Every year, 3 million people die from diarrhea alone. Consequently, infant mortality rates are still high in villages like this. And even if you manage to survive into adulthood, life expectancy is only 45 years.
So there's nothing romantic here about staying on the land with these people.
No, it's not romantic for the people who are staying here. It's romantic for the people in Los Angeles or wherever they are to look at these people, look at them as a kind of a living museum which they can come and enjoy and go back to their five-star lifestyle. But for the people here, given a choice, they would jump ship at the first opportunity. Most of us who do not live in this condition fail to realize that agriculture is not their lifestyle. You know, it is their occupation. It's an economic activity. Most of us seem to romanticize their agriculture as their lifestyle. It's not for them if you ask them. Which means that if these people can improve their agricultural productivity, they would have a better income, which would improve their quality of life, quality of housing, quality of everything. If technology can bring benefits, I think it will be criminal on our part to deny them the option to utilize and gain maximum advantage that a new technology can provide.
It was clear from my visit to India that despite the best efforts of scientists like Dr. Borlaug and Dr. Swaminathan, there was still much to be done in improving the agriculture and the lives of people here.
Despite the Green Revolution, we still have about 200 million people who go to bed hungry every day, just in India alone, and that number is probably going to keep increasing.
The Green Revolution was a spectacular scientific success. It literally saved the lives of millions of people. However, the breeding technology used for the Green Revolution is limited and can only go so far. In order to feed India's growing population, a second revolution is needed. And for this, people are looking to genetic engineering.
For most of agricultural history, farmers have had to rely on genetic mutations or chance crossings between one plant and another in order to improve their crops. And even after scientists had learned in the early part of the 20th century how to use genetics and breed plant varieties, their methods were still crude. This kind of breeding involved mixing together thousands of genes from one plant with thousands of genes from another, without being able to predict accurately what the result might be.
The process of plant breeding is the science of genetics, and it is the science of genetic engineering to create new plants with better genetic constitutions that have a higher yield, that produce more. And so people have been selecting for better plants all this time, but they've had limitations. They've only been able to work with plants that they can cross, and they've only been able to work with entire genomes. So for example, if they bring a desirable trait in from one plant, they may bring in 10 undesirable traits at the same time. And it's a very hard and difficult thing to weed out and get rid of the undesirable traits and hold on to the good desirable trait, like greater yield or resistance to a disease or something like that.
However, by the 1970s, scientists were beginning to learn how to identify individual genes and to discover their function. One of these scientists was Luis Herrera Estrella.
When I started working in plant molecular biology, it was a very exciting time because plant genes were started to be isolated, and the whole field of plant biology was developing.
Luis was one of a number of scientists worldwide searching to find some way of transferring individual genes from one plant to another. The answer came in 1981 when they hit upon a natural soil bacterium which did just that. 2 years later, Luis and others successfully transferred a bacterial antibiotic resistance gene into a tobacco plant, and modern plant genetic engineering was born.
So when we did these experiments and we successfully introduced genetic material from other organisms into plant cells, it was a big moment of our lives, because that opened the possibility of changing the way agriculture is done in the world. So it was very exciting because we realized the potential of this technology.
Researchers immediately set to work to see if they could turn theory into practice and use the new genetic engineering techniques to develop better crops. One of the first big successes came 3 years later, in 1986, when scientists succeeded in building disease resistance into a tomato plant. In 1987, scientists announced that they had engineered the first insect-resistant plant. And the following year, they created herbicide resistance for the first time in a crop. Only after more than 10 years of testing, after countless laboratory and field trials, were the first genetically modified seeds made available to farmers. But then the results were staggering. Farmer Max Smith found that using the new technology, he was able to grow healthy and high-yielding crops, but using far fewer chemicals to do it.
We've used from 20 to 40% less herbicide and less insecticide since the GMO products have come out here. This has saved a lot of trips over the field, and it's just a more chemically free crop now.
How does this affect what you get in the grocery store in terms of health?
Well, the best way I could describe that is, what would you rather have? Would you rather have a corn that had bugs in it and had
been sprayed with insecticide a couple of times, or would you rather have a BT engineered corn where there's never been any insecticide put on it, it's chemically free, and there's no insects in it, and it's a very safe food to eat?
The advantages of using genetically enhanced seeds were so obvious to farmers that within just a few years, they were turning to the new technology in droves. Already, 60% of all soybeans grown in the United States comes from genetically modified seed. Worldwide, there is now over 100 million acres of GMO crops being grown. Recently, scientists have begun to think of entirely new ways to improve plants. Dr. David Aber is especially excited by the possible medical applications.
What genetic engineering of plants has to offer is the ability to enhance the plants we have now. For instance, we can increase the amount of vitamin E in a ear of corn by 8 or 10-fold and make it so you don't have to take a vitamin pill with vitamin E in it. We may be able to get it just by eating our food supply.
This is already being done with so-called golden rice, which has been engineered to contain higher levels of vitamin A. This is aimed at addressing a huge problem in the third world of so-called hidden hunger, where an inadequate diet leads to chronic vitamin and iron deficiency.
What happens if you don't have enough vitamin A in your diet is that you simply go blind. You also have a problem that within a year or two you would die, because not only you go blind, but you also get predisposed to a lot of diseases like measles and malaria.
Professor Prakash is one of a number of scientists working on improving the nutritional content of foods commonly consumed in developing countries.
Biotechnology has already shown massive promise in addressing some of the problems of hidden hunger. And so in sweet potato, our research at Tuskegee University has helped us to increase the protein content 6-fold.
Luis Herrera Estrella is now attempting to address another huge problem facing farmers in the third world, which is the presence of large amounts of poisonous aluminum in the soil.
One of the most important constraints for agricultural production in tropical and subtropical areas of the world is aluminum toxicity. Aluminum toxicity is present in acidic soils, which comprise about 40% of the world's arable land. In soils which have aluminum toxicity, productivity can be reduced about 80%. And these areas is where poor farmers grow in Africa, Asia, and Latin America.
To solve this problem, Luis has used genes taken from wild plants which grow well in aluminum-rich soils.
So we have identified these genes which are responsible for this characteristic of wild plants which are adapted to grow in these soils, and we have transferred them to useful crops which have a much better potential to produce in acidic soils.
Scientists from around the world are attempting to use genetic engineering to address all sorts of agricultural problems, from engineering fruits and vegetables to stay fresh longer, to making plants which are drought resistant. In short, they are showing how genetic engineering might be used to transform agriculture, both in the advanced industrial world and in the world's poorest regions.
I have the dream and the vision that we will be able to make every individual on this earth have enough food and of the right kind of food before the end of this century because of the continuing use of genetics.
GM technology has the potential to make starvation and hunger a thing of the past.
But the revolution which has been brought about by plant genetics has implications beyond the production of food.
We're going to learn about the information that's in every gene of a plant. We're going to know about all the genetic variants that are responsible for giving us the food that we have. And that is just the beginning. Just think about all of the things that come from plants. We use plants for fiber, we use plants for feed, we use it for plants for drugs. We're going to be able to improve all of these things. We're going to live in a world where genetics can really be deployed to serve all kinds of purposes.
However, genetic engineering has not been universally welcomed. There was a small but vocal group of people, primarily in Europe, who were opposed to the use of genetically modified crops.
Genetically engineered food is not healthy. And all of us are saying we want chemical-free food from farmers that we trust, food that we can afford.
I think that if there's any risk involved whatsoever with the food we eat, we shouldn't take that risk.
But how different is genetic engineering from what we've been doing already? Scientists claim that it is essentially a more accurate version of traditional plant breeding, and therefore genetic engineering is, if anything, safer than what went before.
Genetic engineering allows you to work in a much more precise way with single individual genes. So in that regard, it's much more pure and much more controlled, and perhaps even more safe.
But critics also argue that modern genetic engineering is more unnatural than traditional plant breeding because scientists can now transfer genes between very different species. However, scientists point out that even species which seem totally unrelated, such as trees and humans, are not as different as they seem, and in fact, share many genes.
And what do you say to the critics who contend that there's something unnatural about transferring a gene from one species to another species?
Well, I would say that there's nothing really to worry about. I share a lot of genes in common with this bamboo. I mean, we have our ancestors were linked at one time, and so we now share the same types of cells, the same types of structures in the cells, and we share DNA. So in many ways, this plant and I are not very different.
To investigate further, I decided to look at a gene database at my laboratory in UCLA. So you can find a gene in a plant that's similar to what we have in human cells?
Yes. In fact, I could show you how similar we are. This is the human, and this is the plant.
It's amazing. This is the human, IRGQRK, and this is the plant, IRAQRK. They're almost identical.
Right.
The genes in your chromosomes in your cells would be the same as the genes you've been studying in these bean plants. Is that correct?
Yes.
Scientists argue that genetically modified foods are simply the most studied and tested foodstuffs known to man.
There is no example during agricultural history of plant varieties being tested so carefully as GM crops. These tests have been done since already more than 10 years ago. They have been tested in the field. They have been tested in terms of their potential to harm human health. And it's unprecedented how carefully these plants have been tested to make sure that they don't cause problems to the environment or to human health.
What's more, plant scientists argue that the new technology, far from damaging the environment, could be of enormous benefit. Ann Hirsch is working to develop plants which don't need fertilizer, which would be a huge help to both farmers and the environment.
What we do in this country is we over-fertilize things. And so all this goes into lakes and riverways, winds up in a process called eutrophication, where you have an increase in algal growth. This reduces oxygen in these waterways, and all fish die. There are plants, the legumes, alfalfa and peas, that make their own fertilizer. Now, if we could understand the genes and find those genes and transfer that ability to other plants, like rice or corn or wheat, we would not have to rely on external fertilizer use. There's no way we could do this by traditional plant breeding.
And according to Max Smith, another area in which the new technology has had a positive environmental impact is soil preservation, since farmers no longer have to till their lands.
So Max, how has the new genetically engineered varieties of soybean allowed you to conserve the soil?
Well, this field here is a prime example. If you look down here, Bob, see all this organic matter we've got right here? You pick this up, this is a lot of this trash is from last year's crop.
I see some soybeans in here.
Yeah, this is a soybean crop that we're in, and here's the corn stalks from last year. There's a cob from last year's corn. And this technology's allowed us to leave this residue on top of the ground, and this keeps the erosion, keeps the water. Whenever we get, occasionally we'll get a 2 to 3 inch rainfall, and this soil used to erode and leave ditches down through it. It just carved a ditch right through it. And with all this trash on here today, it keeps happening, and we're real proud of how we've kept this soil right here where it needs to be.
And you've been able to do this because of the genetically engineered varieties?
That's correct. 25 years ago, we had as high as 20 to 30 ton losses per year on an acre basis, losing soil. Today, those soil losses are almost down to zero.
I'm an environmentalist, and I think the thesis that new genetics and chemistry is bad for the environment is wrong. And we've got to face the future with seeing technical innovation as being a salvation to many of these problems and not a menace to the environment.
Bob, I'm extremely optimistic about the new technologies that will be used in agriculture. There will be technologies that will essentially remove the need for agrochemicals. We'll have virus resistance, resistance to fungi, resistance to nematodes, resistance to insects, resistance to bacteria. We'll have a clean agriculture, an agriculture that will be what the natural foods industry dreams of, what the organic industry dreams of, and comes through good genetics.
Plant scientists say we really should not be worried about this new method of genetically modifying plants. Yes, it's messing about with nature, but that's what we've been doing ever since agriculture began.
We have been messing with nature for 10,000 years. The day we walked out of the caves, from stop being hunters and gatherers, when we started practicing agriculture, we've been messing with nature. Kiwi fruit is about 50 years old. Talk about strawberries, it's just about 200 years old. Orange-fleshed carrots is about 300 years old. None of this existed 300 years ago, and these are all there because of our messing with nature.
You think nature was responsible for producing green apples, and red apples, and red and yellow apples, and green and red apples, and orange and red apples, and dark red apples, and small apples, and larger apples? Nature wasn't responsible for this. Man was responsible for selecting those variants in nature and preserving them and using them for these beautiful foods that we have inside the store today. Look at this plant. It has all these leaves on it. This is a relative of this plant. These plants look very, very different from each other, but yet they're exactly the same species, they're exactly the same family, they can cross with each other, they can pollinate each other, they're self-fertile with each other, and look at the enormous differences. Here we have all these leaves, here we have the flower heads essentially, and little tiny leaves. And so what man did, which is remarkable, is use his ingenuity in order to engineer different parts of the plant. This is a monument, a cathedral to human imagination and human ingenuity. Nature did not produce this abundance of food. It was done by man. And when people say that we shouldn't tamper with nature, look all around you. Wake up. We've done it. We're benefiting from it. And genetic engineering technology is an extension of what we've done.
But despite the weight of scientific evidence and the widespread use of genetically modified crops, some researchers nevertheless find that their work in this area is being hindered.
We have faced major problems to do these experiments in the field because now activists have influenced the Mexican government to stop all these type of experiments. So we are developing plant varieties that are going to be useful for small farmers, and this ecologist group have created problems which are delaying our research already for more than 2 years.
And it's not just research that is being affected. The most shocking thing to me is that this prejudice is already starting to affect emergency provision of food, as I found out in India when I visited the aid organization CARE. CARE had been distributing GMOs passed for human consumption in the United States to disaster victims in India, and was nearly closed down as a result.
The individuals who run CARE here would not speak on camera because they have been accused of using the India people as a testing ground for poisons, meaning poisons genetically modified corn and soybeans obtained from the United States. activists who are against genetic engineering and against the advancement of this technology have effectively intimidated them, and they're worried that their good work here in India will be hampered and, in fact, perhaps eliminated. What's absolutely outrageous about this is that activists